Factor completely. X plus 4, the quantity cubed, minus 64z cubed. In order to factor the difference of cubics, we must make sure everything has an exponent 3. Rewriting that 64 with an exponent 3 would give us a 4 cubed z cubed. And then I write what I see without exponent 3, which is in parentheses x plus 4 minus 4z. And then in another very large set of parentheses, I write my x plus 4, but this first one needs to be squared. Then I multiply these two together, 4z times x plus 4, and then I square that last term, which would give me a 16z squared. The last sign is always a plus, but this other sign is the opposite of what you started with. This has subtraction already, so this is a plus. Now in the back of the book, when you go to look at this answer, they'll clear out all the parentheses. They'll make this look as good as possible. So if you remember how to multiply out an x plus 4 squared, do not distribute the exponent, but you will get x squared plus 8x plus 16 plus 4z x plus 16z plus 16z squared. So the answer in the back of the book clears out all of the parentheses. And again, you might want to go off to the side of your paper to make sure that this x plus 4 squared is in fact what I said. So x plus 4 times x plus 4. Multiplying this all the way out, you should get x squared plus 8x plus 16. In this next example, as you will see in the book, when we are given 4 terms and they want you to factor 3 of them together, they generally put in the parentheses. So I need to factor this first. It is a trinomial, so I do 2 sets of parentheses, and breaking down the x squared would give me an x. Breaking down the 4y squared would give me a 2y. And checking the signs. The last one is a plus, meaning that they will be the same. And then I just look here to see what they are. They're both pluses. I still have minus 25 here in the back. Okay, rewriting this as x plus 2y squared, because it shows up twice, minus 25. It might be a little bit easier to see that this is the difference of perfect squares. For the difference of perfect squares, you want to write the same thing twice, one with a plus and one with a minus. The 25 is pretty easy to see and break down as a 5 in the back. But how do we break down x plus 2y squared? Well, it means that I have an x plus 2y twice. So this is factored completely. Again, the back of the book will write it without parentheses. So it would appear to be an x plus 2y plus 5 times an x plus 2y minus 5.